So we're here to talk through this ripple effect puzzle by Grant Fikes. It's a number placement puzzle and will have a lot of things in common, at least in how I solve it with Sudoku puzzles, often where my notation is focusing on spots where I know I have an either or choice of remaining digits, but can get through otherwise pretty well. One thing that is also true of Sudoku puzzles is while it seems that you can make lots and lots of small points of progress around the grid all the time, the most critical thing to do these puzzles well is to always focus on every single consequence of the number you write. So if I write this 1, I'm in a region that has 3 cells around it, 2 of which now can't be a 1, and so I quickly know this cell is a 1. This doesn't give me anything below it, so I move back to this number I write and see on the right I also have a situation where I have 1 remaining cell that gives me a 1. This is nearby a cell that now has only one option for it, which is a 2. So I look and see, well, I have a 2 to the left, 2 spots, can't be the top spot, get a 2 there. I can fill out this group, but I'm not done thinking about this 2 yet. If I come across, a 2 can sit in just one of these spots, but I actually have now 2 2s that cancel that out. Similarly, still thinking about just this 2, looking down, it's canceling this spot, another 2 in the neighborhood cancels this spot. You have 2 like this. This is the aspect of maybe why it's called ripple effect. At least a single digit quickly leads to lots and lots of progress, and a lot of the times this is very local in nature, which means that just staying focused in one area and making sure you're logging everything you can is helpful. So what's the next right place to do that? Well, here I can at least mark before I leave this area that a 2 is in one of those cells. So once I know something about a 2, say in this cell or in these cells, I can force this. And obviously up here, I place this 2, but it gives information just nearby. I get something like this, a 2 in one of those cells. This is sort of how I make the notation. And now we should probably just go around and just focus on the digits 1, where we can place them, fill out things as we find them. 1s don't go in these spots, so we think that one of those is a 1. It just has one option left. This is a 1. There's a lot of space around it, so there's not much information in those adjoining groups. There's not much information in these adjoining groups right now. May not be too helpful. We can write that at least in this region, this 1 leaves 2 spots. Down here there's a 1, so 1 in those cells. Down here is a 1, so 1 in those cells. Down here is a 1, that forces a 1, 2. This 1 cancels this note, we get a 1. Cancels that note, we get a 1. This 1 actually touches the region just above it. 2's in those sorts of cells. And it's not that there's anything particularly difficult at this stage of the puzzle with the way we're searching through the numbers, but it's just critical that you keep maintaining the inventory as you go through. Situation like this, we've actually placed a lot of 1s in this area. It turns out that every cell in this region, except the top one, has a 1 touching it, and that gives us kind of the next mini breakthrough where we can fill out this spot. And I'll just log the remaining information I know about this kind of cell. I get a 1 has to be here. This is a 3, 4. When I'm down to pairs, it's useful to mark those in the grid. Now, you often get to a time in puzzles where you need to transition to higher numbers, and you may not immediately look in this group and say, well, I should be considering 3s for it, but right now the 3s that we have as footholds are in these 2 spots. Turns out a 3 can't sit here, it can't sit here. So you get this 3, that forces the 1 next to it. The remaining cell can only be a 4. And now we'll get to situations where having some of these notations really helps. So ask yourself where in this region a 4 can sit. It's not going to sit in these cells because of that number above it. You'll also notice it can't sit in this cell because we'll cancel a 4 in both of the adjacent cells. So a 4 has to be down here. This 4 that we've written in the grid has a reach 1, 2, 3, 4 above, or 1, 2, 3, 4 below, but from the other side of this number. But the thing that I'll have you see is this 4 cancels the option in this cell, and so we can place it like so. We get a case where we have a 3, 4 pair coming up here, get a 1. we've been making some progress with 3s and 4s, so let's come back to those numbers. Looking more to the right, there's only one spot for a 3. Because of our notes, we quickly see it forces the other spot for the 2. If we then come back and look at digit 1, again focused in this just small area, this is the only spot for a 4. That is the rest of the 5s. Let's, I guess, stick with 3s for a bit. Looking over here, get a 3. Here's a moment where if we just do a full inventory, we'll eventually see what's critical in this region, but there's something about the shape of this cell and the adjacent regions which suggests this number eliminates a lot around it, particularly if it's 2, 3, 4, 5. This digit has to be the same as that digit. If we look in the grid, this is a similar kind of space. We know it's not a 1, but whatever number goes in here will also go in there. So can it be a 2? No. Can it be a 3? No. I guess this can be a 5 and not affect that cell, but these kinds of adjoining spots, this cell highly affects that one, this cell highly affects that one. Anyway, this is a cell you'd think to see when you fill it with a 2. Right next to it is a cell that doesn't have a lot of choices. We can do a little more than just that. We can mark 3, 3 there. We have 4 in one of those cells. If I'm coming to this top region, I'm interested in looking at the digit 2. Then I look at the digit 3, and I see that there's only one spot for a 3. So I actually get here. This is 4, 5 left over. Currently it's forced. A lot of digits to now just look in the neighborhood about, but the 2 forces this 2. We already noted that that would make this be a 3. This 3 forces this is a 3, which forces a 1 there, 4 there, 5 there. All sort of written into our notes. This 4 forces that orientation. We've just filled in this region, so let's keep looking down on this edge. The 3 cancels a lot around it. We get a 3, force up a 1, force over a 2. Just got this 3. This is going to be the hardest region of all to fill. It's also the largest in the puzzle of size 7. These 3 regions that are of size 6 will also be a little challenging, but what will probably be the end game of the puzzle is placing 6s into some of these to force the 6 over here, and then you'll get a last digit 7. It's pretty typically how the ends of these go. So instead of looking down, I want to look across. This digit's well connected to erase a lot of cells here, as long as this, so we get a 3. Again, still working off this 3. Looking down, I don't get a lot. I see a 3 sort of in these spots, but continue to look across. This was a cell, I didn't note it earlier, but it also sees a lot of space around it. So as soon as I even wrote this as a 3, I can say that this cell here is a 3. That's going to come over here, affect this 3, 4 clue. 4 will come back, affect that clue. So most of the time, what you actually end up doing, because you've made progress too quickly, is going back to spots you've already looked at, but doing an inventory of each of the digits. So as an example, this is a 2, 5, 6 region. Do I have any 2s that see into this? No. That, in this case, there's not going to be a single spot another 2 can force everything. So you're going to need to force this by looking at 5s and 6s. You may not have looked at 5s yet, but if you come across 5, 5, this is a 5, so we're going to have a 2, 6 in some order. And if you want to fight around uniqueness in other circumstances, I think you can probably say now that a 6 has to sit in this cell, or this puzzle won't have one answer, but we'll get that by logic later on. The 3s cancel here. We get a 1 in one of those cells. What else can we do in the short term? We haven't looked in this region yet. Again, it's helpful to look at each of the digits independently. Let's start small. 2, 2, 2, 2. 4 of the 5 cells are eliminated. If I look at the digit 3, it's in one of these spots. If I look at the digit 4, that's canceled, that's canceled. The top one here is canceled. This is 4, this is 3, this is 5, 6 in some order. The 5 has one spot. We get the 6 I guessed by uniqueness would be there. Now we see it by logic, but that's how we force the top. We still have a set of digits to look at here. We've got a few places I can sort of mark a 2 as coming there. A 5 is somewhere in this column. I don't have a great notation for a 5 being in 3 cells, but what I'll have you observe is that obviously eliminates it from this bottom cell. I'm seeing this 5 come across. I can place that. There's an easier thing we can do though right away, which is probably forcing this 2. And once we force the 2, we force this 1. We now actually get that the 5 would have set there. We force it here in this region. There's only that option left. Coming up here, this is a spot where it's a 5 in one of these cells. Here we have 1, 2, 3, 4, 5. So the 5s that are written in solid states eliminate 1, 2, 3, 4 cells. This potential spot for a 5 eliminates that cell. This is the only cell left for it. We now, where's going to be next good spot? Let's come back to this cross and just work into this corner. Digit 1 is not very good. Digit 2 gives us one of those cells. 3 is in the region. Looking at 4 shows that's the only spot left. Looking at the digit 5, now that we've got it below, gives us this placement. That forces a 2. We have a 1, 6. And either this cell is a 1 or that cell is a 6 for uniqueness, but we can't really use that information productively. Looking down this way, 4s aren't in these cells, so they are here. Looking across, still at the digit 4. 4 has to be in the bottom, and this chaining to get this digit is one of the harder last steps of the puzzle, but it's hopefully pretty reasonable to see, particularly if you use this kind of notation. In this region, a 3 is in either of those spots. 6s are in either of these spots. We have a 2 and a 7 to place, and there's not much more information to help us right away. Trying to see, I don't have a 1 that sees into this space. I don't have a 3 currently that sees into this space. There are some things that would build together. For instance, if this were a 3, this cell would be a 3. But something that's maybe going to be more useful is to mark the options for a 3 down in this region. And this will stem if, I guess, either of these cells work, either of those cells work, this cell does not. So we have a circumstance like this, and in the case of the 2, we have a circumstance like this. What's important to see is that in this region, we have just 2 spots for a 2, and this is maybe the hardest kind of logic to see, but when you have 2 potential placements for a number, any cell that sees both of those can't hold that digit, so this cell here can't be a 2. Does that get us very far, very fast? I'm not sure. Looking at the grid carefully here. You'll often find in moments like this there's something you have overlooked, which is going to actually be helpful, and what I've overlooked is this 5 clue doesn't actually have 2 options right now, it just has this option. That now eliminates the options for the 2. We said this cell couldn't be a 2 because of this harder logic, and this cell can't be a 2. So that gives this. This finishes out that group. This 3 finally sets this region, forcing everything around it. We now have just this spot for a 3, leaves this spot alone for the 2. This remains as a 6 with a 7. As I said, the 6 being set forces the 7, and we could have gotten from uniqueness at some stage that the 6 has to be in the top cell to force that. But that finishes the puzzle. I don't find these styles too hard too often. This puzzle had a little bit of a harder edge than Grant's puzzles tend to do, but at least as a number placement style, the ways to use notation as well as the ways to sort of look around local regions and make sure you're exploring all directions as well as everything within the box. It's the same kind of step that works well in Sudoku puzzles, where looking vertically, horizontally, and within groups. With every single placement you make, you won't overrun your progress and end up stalling later on because you don't know where your next step will be. We'll see you again soon.